The National Electrical Code, often referred to as the NEC, serves as the foundational standard for electrical installations in most regions. It provides detailed guidelines to ensure the safety and proper functioning of electrical systems. A common question that arises during electrical inspections concerns the practice of terminating two wires in a single neutral bus bar terminal. The NEC addresses the scenario explicitly, permitting this practice under specific conditions. NEC Section 312.8b directly addresses this situation. It states that conductors of the same circuit, including ground conductors, are permitted to terminate in the same terminal where the total calculated current in the conductors does not exceed the ampacity of the terminal. This allowance is contingent upon the ampacity or current carrying capacity of the terminal itself. The terminal must be rated to safely handle the combined current of both conductors. To clarify, ampacity refers to the maximum amount of electrical current a conductor or device can carry continuously without exceeding its temperature rating. It's a crucial factor in electrical safety, as exceeding the ampacity can lead to overheating, insulation breakdown, and potentially fire hazards. Therefore, the NEC mandates that the terminal used for two conductors must have an ampacity sufficient to accommodate the total current flowing through both wires. Now, NEC Section 110.14c provides further guidance on conductor management within electrical panels. This section states that conductors of the same circuit shall be grouped together wherever practicable. This provision encourages the organization of wiring to enhance clarity and ease of maintenance. While not a strict requirement in the same way as the ampacity rule, grouping conductors of the same circuit is considered a best practice in electrical work. Grouping conductors helps to maintain a logical and easily understandable wiring arrangement. It simplifies troubleshooting and modifications in the future, as it allows electricians to quickly identify and trace the conductors belonging to a specific circuit. When considering the application of these code sections, it's essential to understand the practical implications. Firstly, the total current in the two wires must be carefully calculated. This calculation should account for the expected load on the circuit and any potential future increases in demand. Secondly, the ampacity of the neutral bus bar terminal must be verified. This information is typically found on the terminal itself or in the manufacturer's specifications. If the combined current of the two wires exceeds the terminal's ampacity, then the installation does not comply with the NEC. In such cases, the wiring must be corrected to ensure that each conductor terminates on a separate terminal or that a terminal with a higher ampacity rating is used. The NEC aims to prevent overloading of electrical components, which can lead to dangerous overheating and potential fire hazards. In addition to the NEC, local codes and regulations may impose further restrictions or requirements. It's always advisable to consult with local electrical inspectors or qualified electricians to ensure compliance with all applicable codes. These local authorities have the final say in interpreting and enforcing the electrical codes within their jurisdiction. The interpretation of electrical codes can sometimes be subjective, and inspectors may have different perspectives on specific installations. Open communication with inspectors and a thorough understanding of the NEC are essential for resolving any discrepancies. Electrical codes are not static documents. They are periodically updated to reflect advancements in technology, evolving safety standards, and lessons learned from past incidents. It's crucial for electricians and anyone involved in electrical work to stay informed about the latest code revisions. Failure to adhere to the current edition of the NEC can result in code violations and potential safety hazards. Understanding the NEC is not just about memorizing specific rules, but also about grasping the underlying principles of electrical safety. The code is designed to protect people and property from the hazards associated with electricity. By following the NEC, electricians can ensure that electrical installations are safe, reliable, and compliant with industry standards. The NEC covers a wide range of electrical topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It provides detailed specifications for various types of electrical equipment, such as conductors, cables, circuit breakers, and transformers. The code also addresses specific applications, such as residential wiring, commercial wiring, and industrial wiring. Electrical work is inherently dangerous, and it should only be performed by qualified and licensed electricians. These professionals have the training, experience, and knowledge necessary to perform electrical installations safely and correctly. Attempting to perform electrical work without proper qualifications can result in serious injury or even death. Electricity is a powerful force that demands respect and careful handling. When working with electricity, it's essential to follow all safety precautions, such as de-energizing circuits, wearing appropriate personal protective equipment, and using properly insulated tools. Even seemingly minor electrical shocks can be dangerous, and they should always be treated with caution. Electrical fires are a significant cause of property damage and injuries. They often result from faulty wiring, overloaded circuits, or improper use of electrical equipment. Preventing electrical fires requires diligence in maintaining electrical systems and adhering to safety guidelines. Regular inspections of electrical wiring and equipment can help identify potential hazards before they lead to a fire. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of electricity in the event of an overload or short circuit. These devices are essential for preventing electrical fires and protecting electrical equipment from damage. It's crucial to ensure that overcurrent protection devices are properly sized and installed. Grounding is another critical aspect of electrical safety. Grounding provides a path for fault current to flow back to the source, tripping the overcurrent protection device and preventing electrical shock hazards. A properly grounded electrical system helps to minimize the risk of electrocution in the event of a fault. Electrical codes specify the requirements for grounding electrical systems, including the size and type of grounding conductors. In addition to the NEC, other industry standards and best practices can enhance electrical safety and reliability. These standards may address specific aspects of electrical work, such as wiring methods, equipment installation, or testing procedures. Staying informed about these standards and best practices can help electricians improve their skills and knowledge. Continuing education is essential for electricians to stay up to date with the latest code revisions, technological advancements, and safety practices. Many organizations offer training courses and certification programs for electricians. These programs can help electricians advance their careers and demonstrate their competence. Electrical work is a complex and ever-evolving field. It requires a combination of technical knowledge, practical skills, and a commitment to safety. By adhering to the NEC, following industry standards, and continuously improving their skills, electricians can ensure the safe and reliable operation of electrical systems. The specific interpretation of NEC Section 312.8b and 110.14c in the context of 2 wires per neutral bus bar terminal depends on several factors. These include the specific design of the electrical system, the type of equipment being served, and the local electrical codes. It's important to consult with a qualified electrician or electrical engineer to determine the appropriate wiring methods for a particular application. In some cases, it may be necessary to use a separate neutral terminal for each wire to ensure compliance with the NEC and to maintain the integrity of the electrical system. The decision of whether to use 1 or 2 neutral terminals should be based on a thorough evaluation of the electrical load, the ampacity of the terminals, and the applicable codes and standards. The NEC is not intended to be a substitute for sound engineering judgment. It provides a framework for electrical safety, but it's up to qualified professionals to apply the code in a way that ensures the safer and reliable operation of electrical systems. The electrical industry is constantly evolving, with new technologies and materials being developed all the time. It's important for electricians to stay abreast of these changes and to adapt their practices accordingly. By embracing innovation and continuously learning, electricians can help to improve the safety and efficiency of electrical systems. Electrical safety is a shared responsibility. It's up to everyone involved in the design, installation, and maintenance of electrical systems to ensure that they are safe and compliant with applicable codes and standards. By working together, we can create a safer environment for ourselves and for future generations. In summary, The NEC permits 2 wires per neutral bus bar terminal under specific conditions, primarily when the combined current does not exceed the terminal's ampacity. While NEC section 110.14c encourages grouping of conductors of the same circuit, it doesn't override the ampacity requirement in NEC section 312.8b. It is important to ensure full compliance by referring to the latest edition of the NEC and consulting with local electrical authorities.